Today we'll be looking at balancing chemical equations. So a chemical equation will normally look like this: a reactant forming a product. So this is in a word form. So a reactant is the chemical that's starting the reaction, and the product is the new product that's formed. So in another definition, a reactant is the names of the original substance that we started with, and the product is the names of the new substance that we formed from the reaction. So I have examples here for you. So the first one is easy, and I have these steps I have prepared for you to follow in order to do this the equation balancing. Alright, the first step is to write the equation, and then the second step is to create a table that I've shown below, and the third one is to use trial and error to balance the equation. So the aim is to make sure the left side equals the right side. So we're not destroying anything, so nothing is destroyed. So the atoms in the reactant will just rearrange to form a new product in the product side. So let's start with the first example. The first example, we have a calcium carbonate decomposing to form calcium oxide plus carbon dioxide. Alright, so this is the second step. So we already have the reaction written down. We have to move on to the second step, which is to make this table. So this table has 3 columns. The first column has a title of types of atoms. So the first shows all the different types of atoms in this reaction. The second, or the middle column, shows the number of atoms on the left side, which is the reactant side. And the last column shows the number of atoms on the right side, which is the product side. Okay, so now let's count the number of atoms in the left side. So we have calcium on the left side. So how many calciums are there? There's only 1. Okay, what about how many carbons? There's only 1 as well. Alright, so the first example is easy. Okay, how many oxygens on the left hand side? There's 3. As you can see, there's calcium carbonate, so there's CaCO3, so there's 3 oxygens. Alright, let's move on to the right side. How many atoms are on the right side? So if the right side equals to the left side, then we say the equation is balanced. Okay, so the whole aim is to make sure the left side, the calcium carbonate on the left side, has to equal, so these atoms, the calcium, the carbon, and the oxygen, has to equal the number of calciums and oxygens on the right hand side. So the count has to equal. Alright, so let's see how many calciums are on the right hand side. Okay, there's only 1, and it's bonded in calcium oxide. And how many carbons? There's only 1 in carbon dioxide. And how many oxygens? Alright, there's 1 in calcium oxide and there's 2 in carbon dioxide, so there's a total of 3. That means this equals to the right side, and the left carbon equal to the right carbon, okay, and the oxygen on the reactant side equal to the oxygen on the product side. So this equation is balanced. Alright, let's move on to the second equation, the second example, which is hydrogen peroxide decomposing into water and oxygen. Alright, let's work it out here. So first, we have already the equation written for us. So we have already calcium, the hydrogen peroxide written down. So all we have to do is just move on to the second step, which is to create a table, and I have created it here already. So we have, let's count the number of atoms on the left side, which is on the reactant side. We have how many hydrogens? There's 2 hydrogens. It's already shown H2 means there's 2 hydrogens. How about the oxygen? There's now 2 oxygens on the reactant side. Alright, that's already bonded to the hydrogen peroxide as a 1 compound. Alright. Now let's look at the right hand side. Alright, just zoom in so you can see it properly. Alright, now number of hydrogens on the right hand side. There's 2 bonded to as a H2O, and how many oxygens are there. Now there's 2 as an oxygen gas, and there's 1 bonded to the water, so there's total of 3. Wow, now this shows that this equals to the reactant side. The hydrogen on the reactant side will equal to the hydrogen on the product side, okay, but the oxygen in the reactant side doesn't equal to the oxygen in the product side. So now we have to do something. What we have to do is to use a trial and error, which is the last step. Use trial and error to balance the equation. So now what we have to do is we have to somehow put a whole number in front of one of these chemicals to make the oxygens balanced, because the problem is the oxygen is not the hydrogen. The hydrogen is balanced. We just have to balance the oxygen. So what we're going to have to do is we're going to put 2 in front of the H2O right here and rewrite the equation again. So we have hydrogen peroxide decomposing to 2 loss of water, H2O, plus an oxygen gas. Alright, so that is just a gas that escapes to the environment. Alright, so what happens is that, like, now we have 2 times 2, which is 4 hydrogens on the right hand side. So now what we have on the right hand side is 4 hydrogens. Okay, let's see how many we have on the reactant side. But okay, the reactant side hydrogen shows there's only 2, so we have to do something about that. Now we're gonna put another big 2 in front of the hydrogen peroxide. Okay, now let's see if that balances. Now, like, 2 times 2, which makes it 4. So now there's a 4 hydrogens on the reactant side, and there's 4 oxygens as well. Alright, let's see if that now balances with the reactant side, the product side. We have 2 oxygens in the H2O, 2 loss of water here. So the big 2 means 2 loss of water. So that's 2 oxygens plus the other separated oxygen gas outside here. There's 2 here plus 2, that's 4. Alright, so now we can say with the balance the equation, there's 4 hydrogens on the reactant side and 4 hydrogens in the product side. Also, there's 4 oxygens in the reactant side and 4 oxygens in the product side. And this is the final balanced equation. Alright. So that's not the only type of equation or the only format that you will see in an exam or in a test case. The teacher might write the equation in a word format like that. You can see here, like lithium plus oxygen forming lithium oxide. Your job is to turn this into chemical symbols like here. So what you need to know is, like, you need to know the chemical symbols and what the product that's formed, how to write it down in a chemical symbol. So, like, what does it look like? So okay, we have here, so we're going to be following the same steps as before. We're going to write the equation that's already written here for us, and then we're going to create a table and then use trial and error to balance the equation. So I already have the table prepared here, so let's look at the different types of atoms that we have in this reaction. Alright, we have a lithium atom and an oxygen atom, so we have them here already written down. Okay, so let's see how many are there on the reactant side. There's only 1 lithium atom in the reactant side and 2 oxygens. Alright, how many we have on the product side? There's 2 lithium atoms somehow on the product side and only 1 oxygen. So how are we going to balance this? So we're going to have to use trial and error, like put numbers in front of the chemicals, but I always recommend you to put the number in front of the product side and try to balance things out. Like here, we're going to put 2. If we try to put 2 here, since this is a trial and error, let's see what happens. So if we have 2 in front of the lithium oxide, we're going to have a 4 lithium. Okay, we're going to have a 4 lithium and 2 oxygens. Okay, but that will contradict it will not still equal to the product side lithium. So what we're going to do is we're going to have to put 4 here, 4 lithium ions. So 4 lithium atoms in front, like, so we put 4 in front of the lithium to make 4 lithium atoms. Okay, so that will equal to the lithium on the product side, and the oxygen, we don't have to do anything to the oxygen because there's already 2 on the product side and we have already 2. Alright, so we're gonna have 4 from the transformed equation and 2 didn't change. Okay, so now we're gonna write the final equation, which is 4 lithium atoms, okay, react with oxygen, 2 oxygen atoms to produce 2 lots of lithium oxide compound, okay, or lithium oxide ion. Okay, so that's the formula of the ion that's formed. All right, and that's the equation that will give you the full mark. Okay, so that's the balanced equation.